What's up everybody, long time no see. Today I'm gonna record another video to explain you the concept of recursion. Actually, this question was asked to me during my job interview, and apparently it's not gonna be that kind of difficult problem, but I think it's kind of worth checking you the basic concept of recursion. So what my employer asked me to do was design a function called count7. It can't be like count anything, but which takes one integer and checks the number of 7. How many, the digit of 7 is going to appear in that number integer n. So these are some couple of test cases that was given. So if you see the 1, 2, 3, 7, 3, 2, 1, whatever this large number, the output should 1 because there's like one count of 7. And if you see that 1, 7, 7, 1, 3, output should be 3. There's a 3 case of 7. 7, 7, 7, 7, 7, 7. There are 6 7s, and 1, 2, 3, 4, 5, 6. There's no 7. So it doesn't have to be like 6 digits, 7 digits. No matter which end that you have, the output should be as following. So how can we code it up in Python or in Java or in any other language that you think? There are a lot of ways you can do it, but in particular, in this case, you can of course use dictionary, you can use like list, you can use iterator, but this time employer particularly asked me to design this using recursion. So what is recursion? Recursion is a function that calls itself, and in order for us to implement recursion, we'd have a base case and its body. So let's think of how do we construct a base case. What's going to be the base case? So what is the pattern that keeps iterating itself so that we can take out the pattern? As you see, we in this section, we're going to mostly use the concept called double slash and mod operator, meaning that we take the chunk of double slash or slash in Python, which means we take the quotient of it when we use division and the remainder of it. So what I mean by that is, as a test cases, okay, I'll show you what this means. So basically what I'm saying here is if you have the number was 1, 2, 3, 4, 5, 6, if you use like double slash 10, it gives you the quotient of 1, 2, 3, 4, 5, 6, and if you mod 10, right, then it will give you 6. So every time, this is pretty useful when you do some integer calculation. You can use like double slash 10 to get the quotient of it, and you take the remainder and you just kind of keep doing this, meaning that if you do another this, then it keeps moving on and like this, so we're gonna use that, meaning that if that n is gonna be terminated n, so what I mean by that n is n double slash 10, when n is gonna be n equal n double slash 10, gonna be like, so n is gonna be keep decreasing, and we're gonna take this into account when we construct our recursion anyhow. So what is that base case? Base case is if the n reaches out, if the n hits the bottom, meaning that if n runs out of its digits, meaning that it reaches all the way to the left hand side, and if that n is not divisible by 7, okay, what we want to return is we want to return 0 because there's no count of 7 apparently. So this, we're just hitting the very basic root of the case. When we run off the digits, we keep going to the left hand side. If we hit it at 0, and if that number is not the multiple of 7, then we return 0. If the n is still 0, and if that is a multiple of 0, if the last digit n, then we want to return 1. Now, else otherwise, meaning that if we do not return, so these two again are the base case. And then the next thing we want to do is during this iteration time, we want to check whether that number of digits that we're checking at that point is a multiple of 7 or not. The way we do it is if that number is 7th digit or 7 multiple, if that number is 7, I'm sorry, not the multiple, I'm sorry, we want to return it 1 plus whatever the previous count 7. This is where the recursion kicks in, as you see. So what I mean by that is if that during the iteration, if we find the 7, we want to plus 1 plus whatever the previous ones, and the previous one's going to be returned from there, if that makes sense. Else, meaning that if that number is not 7, we want to just return the previous the number of times, if that makes sense. So it's gonna anyhow the first bottom cases. I'm gonna keep returning 1, and it's gonna keep incrementing here. Otherwise, it's just returning that, and then it's gonna just return it at the decimal, if that makes sense. So please leave any comments if you think that something is not clear. I'll be happy to see you my code, and you can kind of draw it on pencil and implement it. So this is a very interesting algorithm that every time the idea of recursion is it is easy to write a code, but it's hard to think of every single scenario unless you hit it really at the bottom of the case and you fundamentally like crack it down. So let me call it, and how about print this function, and I want to 1, 2, 3. I want to feed these numbers of n here basically, and see if what we can return. I want to copy and paste it because we have 4 test cases, and second test case is gonna be this one, and then third test case is gonna be this one. The last test case is gonna be this one. This is hopefully the 1360. Perfect. So that's was what we're expecting. Thank you for watching my video. I hope you enjoy my channel and understand what's going on in this recursion. It's good to understand recursion. I hope you have a great day. Thank you.